Welcome everyone into science and engineering world, where we enjoy ourselves doing mathematics, much more mathematics. Let's grab our pen and paper and go into the classroom. In this presentation, I want us to look into triangle and see more of the properties. This time around, we want to look at the properties of triangles which are not right. Call it right because it's a right-angled triangle. My name is Olutola Fakehinde. There are basically 6 types of triangles. The first one is right, that I always call right, which is right-angled triangle with its 90 degrees here, and the line facing it as hypotenuse. I've done some video clips on this and I put the link above. Then we have here the second one is equilateral triangle, that is all its sides are equal and all its angles are equal. So we have also worked with this in another video clips that I put above. All the angles equal, all the sides equal. And the third one is isosceles triangle, whereby only 2 of its sides are equal and the angles facing them are also equal. So here we have 2 sides equal and the angle facing them are equal. The fourth one is an acute triangle. Acute triangle here means that all the angles are less than 90 degrees. They could be equal like the equilateral triangle, but they may not. The fifth one is obtuse triangle. Obtuse triangle always have one of its angles to be greater than 90 degrees. So all the angles, one of these, like this, is greater than 90 degrees. Then we have the scaling triangle. Scaling triangle is a little different from obtuse triangle in the sense that none of its angles are equal and none of its sides are equal. Obtuse angle can still have 2 sides equal, but they have one angle greater than 90 degrees. Same thing as scaling has one angle greater than 90 degrees, which is obtuse, and the only difference is that none of its properties are equal. I believe we can conveniently find the 6 properties of a right-angled triangle using Pythagoras theorem and then trigonometric ratios, which I have demonstrated in some videos previously, and I will put their links above and then below in the comment sections. Now we need to find the properties of further triangles where the Pythagoras theorem and the trigonometric ratios may not work. In this case, we are going to be looking at 2 methods to be able to find the properties. Now in this triangle ABC, we have the capital letter for angles and the small letters for the sides. And sine rule says that the ratio of a side and the angle facing it will be equal to the ratio of the other side and the angle facing that side, and the third one similarly. So let's write it out. It says here, sine rule says that A over the sine of the angle facing it is capital A will be equal to B over the angle facing it is capital B. will also be equal to C over the angle facing it, sine of C. Now, if you are looking for the side, then this is a good way to start by putting the side as a numerator and the sine of the angles at denominator. However, if you are looking for the angle, then it's also easier or better to put the angle at the numerator, like sine A over A will be equal to sine B over B, which will also be equal to sine C over C. You see that they are almost the same thing, and just for convenience sake, that is why you put one as numerator and the other as denominator. In similar vein, cos rule says something similar to what we have in a right-angled triangle. But because it's not a right-angled triangle, then there is a modification to it. Cosine rule says that A squared will be equal to B squared plus C squared. Now, like I said, this is like a Pythagoras theorem. Now, the modification here is you have to take the product of the two sides inside here, multiply by 2, so 2BC, and the cos of the line we are looking for. So cos A. Now, by the time we write the second one or the third one, it will be clearer. So now let's look for B. So we say B squared equals to A squared plus C squared minus 2 times AC cos of B. So we can also write for the third one and say C squared equals to A squared plus B squared minus 2AB cos of C as capital. By now we should be able to find all the 6 properties of any triangle at all. So we need to now find the area of a triangle. And there are 3 methods we want to look at here. In looking at a triangle like this, we can have here the first method, which says area of this triangle will be equal to half of the base, that's half times base, times perpendicular height. Good. Any side can be the base. Either A or B or C can be the base. But the perpendicular distance is what is important here. So for example, if C is the base, then we need to find a perpendicular distance to this base that is coming from the apex. That is, we need to find a line perpendicular to that. So this will be the height h. And if we put A as the base as well, then you need to find a line from A perpendicular to BC. And this is very important to this expression. Let us look at the second method. In the second method again, we are looking at that triangle, so which is method number 2. Method number 2 says here that area is equal to half, just like what we have before, but half of two known sides. That is half of, for example, if we know A and B, that is half of A times B times the sine of the angle included. So we are talking of A here and B there, and if we know this angle here, let's say this is theta, then that will be sine times sine theta. So in this expression, what is important now is we have two known sides and the angle that is included, which are important. So we have half multiplied by the two sides and then multiplied by the sine of the angle included. The third one is sometimes called Hero's formula. So it says that area is equal to the square root of S into S minus A into S minus B into S minus C. So where S equals to A plus B plus C over 2. So this is how to find an area of a triangle that you don't know any of the angles. And this is sometimes called Hero's formula. And that is when you don't know any of the angles, then you can use Hero's formula to find the area of the triangle. So any of these three we can use in any of the triangles we have mentioned above. I designed this to demonstrate the use of triangles. I believe we can now find the properties of any triangle, either the length, the angle, or even the area. Now, in summary, we have looked at the sine rule and the cosine rule, and then the three methods to find the area of any triangle. And I'm sure we can now deal with triangles in any various form they may appear. So if you find this video very useful, give a thumb up, share this video with others so that they can enjoy similar things we've been enjoying here. Make comments, because there are different ways or many methods by which you can solve problems. And then subscribe, like I've encouraged at the top. I would like you to please subscribe to this channel so that you can fly to other parts of the world. And like I keep saying, keep having fun, because we have fun here by looking at so many ways of solving problems. And until the next time we meet, keep studying.